The unguided communication or the unguided transmission goes through the name also of wireless communication. It plays a very crucial part in our lives, in things like mobiles, laptops, things that we need to move with, things that we cannot live while there is a cable connecting that laptop or that mobile to the internet. We need to go places and visit and just stay connected to the internet. So here happens to exist the science of the wireless communication. So we no longer need to connect the A and B through a wire. We need like device A and to the and B, let's say a server or the internet, through a wire. Instead now these A and B connect through air. Is that air? Is that the question? So what happens in order to A and B communicate? Is that oxygen? Is that air? Just nitrogen or something? In order to understand what is going on in there, we need to use the electromagnetic waves and have an idea about the electromagnetic spectrum. So the first thing we are going to see is the electromagnetic spectrum. So it's like a wave, a very broad wave, and this wave just goes to become even shorter. This shortness in the wave goes to be until it goes to be of a very low something. This low something is in time. If we say how much times this peak come again, so let's say this peak appeared and it came back again, so this time is called one, for instance, 1 second. So if this peak and peak came twice, so coming twice is called how frequent it came. So here it's the frequency. So in a let's say in a time lapse like of this has like 5 or 6 times the wave came in. So say that here the frequency is higher. The higher the frequency, the lower the wavelength. Okay, so the wavelength is inverse to the frequency. So here is the high wavelength and here is high frequency, and in order that high frequency to happen, a low wavelength comes in place. So why do I explain any of this, and why is this even something? So the communication of the wireless communication actually comes out from this part. It's just solely this part is the one performing the wireless communication. So here exists in a high wavelength the radio wave. Okay, so here exists the radio waves, and the section of this radio wave on a high frequency of the radio wave, still on this frequency band, is the microwave. Okay, and also there is the radio wave, since the radio wave and microwave. So now there is also the infrared, and here exists the visible light or the visible spectrum. Here is the part we see, and here then exists the ultraviolet, the X-ray, and also the gamma ray or the gamma. Okay, so these parts, the part on the left especially, the part on the right I mean, are called the ionizing part, but this part here is the ones we use in our communication, the ones that are non-ionizing. So why is any of this existing? So the ionizing particles do hit our molecules, like say that these are our molecules, so the ionizing ones do hit our molecules and perform interruptions and collisions. So these are usually bad for us as humans. Ultraviolet, the one that comes from the sun, it's bad for our skin, for at least. Then comes the X-ray, the ones that we do for our bones. It's something that's even stronger than the UV. Then comes the gamma rays. The gamma rays are just lethal at this point. It's just if they fall from the sun at a low chance, hitting us and even hurting people who has lower or have the problems with ozone layer. Okay, so any of these on the left we don't, on the right we don't use. We use the non-ionizing, the ones that do not hurt us, like the microwave, radio wave, infrared, and the visible light. So each one of these has a study and has its own personality, has its own specs, has its own way of interacting with. So the first one we are going to talk about is the radio wave. Radio wave is used as you see, it's on a high frequency, so on a low frequency, which means on a high wavelength. This high wavelength makes it able to penetrate. The penetration is the most important factor here in radio waves. So in radio waves, penetration is the best part about it. So it can go through very, very vast areas, like let's say through countries, without being interrupted as strongly as waves that are of high frequency. High frequency usually means high energy. Frequency is associated with energy, which in turn means high energy, which means higher transfer rate, higher data within what we can carry on. But it comes with the problem of the range. Yeah, so if we want to talk about high range, we usually use the radio wave. The radio wave usually comes from antennas, like cellular antennas, and these antennas propagate these radio waves, like the one in the radio waves in our in the old TVs, or the ones in the old radio cassettes. There were old radio cassette, yeah. So this cassette also used radio waves. So it's good for a single base station. This base station propagates all the data that all these devices need. But the problem here, we transfer something that is very, very low on data, like just voice, like it's good for some, for instance, for audio, good for sending small messages, yeah, small messages. But what if we want something higher? So we come back to this spectrum. We see that the radio wave now has something even better, which is the microwave. It's a part of the radio waves that can carry even more data. So here comes the microwave. The microwave, sometimes people think that the microwave is the thing that in our microwave ovens, and yes, it's true. This is the microwave in our microwave ovens. It operates on a certain frequency, usually 2.4 gigahertz. You will find that the internet routers in our homes are also these internet routers also work on the ones we connect to the modems we connect on to the devices are also ones that also work on it's megahertz, yeah, gigahertz. So it also works on microwaves. They usually work on 2.4, and some microwaves or some routers also work on 5 gigahertz. So yeah, so someone may ask, so the radio wave, the microwave, they say it's bad for the health. Is it? It's not. The microwave, the microwave oven that exists in our house is not bad, but it goes through increasing the amplitude of that 2.5 gigahertz, making the energy even higher until it goes into burning, until it goes into making higher heat form. Okay, so radio waves, as we can see, the part on the microwave is capable of carrying more data as the frequency is high here than the radio wave, but also it's low enough of a certain wavelength that is capable of carrying data through good distances in our house. Usually, like our router here in our house usually goes up to 100 meters in 2.4 gigahertz, and on a lower distance, when you increase the 5 gigahertz, can go up to 50 meters or something. Yeah, so the more we increase the frequency, the higher the speed, but the lower the distance, and that goes with the everything in the communication usually. Then comes after this the infrared. The infrared, okay. So the infrared is the ones that is in our remote controllers. So there is a remote controller, and this remote controller has buttons. For instance, if we connect or we click on a button, there is a LED in the end of this remote. When a receiver receives this connection or receives the electromagnetic wave coming from this, it performs an action. So what is this electromagnetic wave? Here it's infrared. Infrared especially can be seen by cameras. So there are cameras that are able to see infrared or even detect infrared. So you can try at home activating a camera, or just making a video and look at the remote controller, and where here is the LED. Here is the LED, okay? Here is the LED, and just click something on the LED, and here is your mobile camera, okay? Or here is your camera. You will see that this sparks a light, like usually a bluish light color. Meanwhile, you can't see it in real life. Like if you clicked on the remote control, you can't see that this LED is doing no color. It's just invisible to our eyes. But for the camera, it detects this color. You can see the color in this LED and this light. So that makes it even better for us to detect that there is a light, or there is an infrared light coming from the remote controller. So this is the usual use of it. The fourth electromagnetic wave that we need to talk about is the visible. And we here don't use any visible light. We can use visible light, but on certain wavelengths and on certain frequencies. So it exists on two uses. Usually it may exist on more, but the most famous one are optical fibers and on the Li-Fis. So Li-Fis are like LEDs or lights, like let's say it's a light here, and it emits light, and the laptops here can detect or can be connected on these internet in the same, let's say this is an office or this is a house, and everything or every device here can be connected to this internet or coming from a light wave. So this is for the Li-Fi. What about the optical fiber? Optical fiber is one of the huge advancements that humans came to, that you can use the light or the laser as a backbone for our communication or for our sending and receiving. So a light beam goes through a cable. This cable is usually having a certain physical specs, like being of glass, plastic, being coated and coming through certain standards, European and American, like IEEE. But the most important part, that it just transfers light, can be laser or can be LED, and has types like multi-mode and single mode, by changing its capability and travel distance. But something like this can go to kilometers. Like sometimes they consider it as man or man communication, or LAN even sometimes if it goes like a single mode. So it can go through kilometers of distance, like cities. It can go through countries, not even cities. So that's why fiber communication or optical fiber is something that is even stronger and transfers data. But optical fiber is not wireless. That's the problem here. So if we are talking about wireless, we will talk about Wi-Fi in the visible spectrum. Anything other than all of these we have talked about is ionizing. Then it's hurting our skin and hurting our bodies. So this was a small talk about wireless communication, and it could have been bigger, but I've spoken about Fresnel zones and free space losses and attenuation, multipath fading, and things like that. But I will just go simple on this, like as an introductory, if it was good, to go on with this. So yeah, I think that's everything for this video, and I hope you liked it, and thank you for watching, and I hope you subscribe and like, and thank you very much.